All right, welcome to bonding. We're going to start with, we have three types of bonds. The first one we're going to start with is ionic bonds because they're usually the hardest bonds to get to understand. So over here I have a few things we're going to discuss. So by the time you finish this video, hopefully you have a little bit of knowledge about what ionic bonds are, how to balance charges, how to write the Lewis dot structure, and some properties of ionic bonds, okay? Excuse me, let's go ahead and get started. All right, so first thing, what is the definition of an ionic bond? Write this down. Please write this down. It is between ions. Okay, so we already talked that we have a cation and we have anions. Usually the cation is the metal because they're positively charged ions, and anions are nonmetals. Okay, so one of the things we need to work with is how to balance the charges. I'm sorry, we'll go back to that. Take that back. We're going to transfer electrons in order to complete the octet. So I'm going to show you kind of what this looks like, and then we'll do a Lewis dot structure, and we'll talk about properties at the end. Okay, so ionic bonds is between ions, and it is a transfer of electrons. Okay, so earlier in one of the earlier lessons we talked about Lewis dot structures, so we'll start there. Okay, so a Lewis dot structure, we'll start with actually we'll start with something a little bit easier, sodium. So sodium is Na, and we have chlorine. Okay, sodium has one valence electron, so our Lewis dot structure has one dot. Our chlorine has 7 valence electrons. So it has 7 dots in its Lewis dot structure. And when we talk about bonding, we're talking about the valence electrons. That's where all the bonding happens, is in the valence electrons. So what happens is sodium is going to give away its one electron, like we talked about earlier, and made ions out of it. So if you remember, sodium's ion is in brackets, and it has a plus charge. Chlorine is going to pick up all of the electrons and have all the electrons, and it will have a negative charge. Now, what does this mean? Okay, so basically what is happening here is this sodium is giving its electron to this chlorine, and so this chlorine is picking up the electron right here. Remember, chlorine is going to keep its same amount of protons, so it's going to have a negative charge because it's picked up another negative charge. Sodium is going to have its same amount of protons, which is 11. It's going to give one away, so it's only going to have 10 valence electrons. Now, if you remember the Bohr model, this is why we kind of looked at the Bohr model. Sodium has 11 valence electrons. Okay, 11 electrons and 1 valence electron, and chlorine has 17 electrons. Okay, so it has 7 in its outer shell. These outer shells are what's bonding together, and there's a transfer from the sodium ion or sodium atom to the chlorine atom, and you end up with sodium and then chlorine together. Okay, so this becomes sodium ion and chloride, which is chloride, right? Sodium ion and chloride. So we get sodium chloride. Okay, table salt. Okay, kind of that idea. So what did we do? Well, we transferred electrons from the cation to the anion, and now both of them, because this one doesn't have anything here, they're both completing an octet. So both of them have 8 electrons in their outer shell now. So they have an 8, which is a complete octet. Okay, so if you notice, there's 2, 4, 6, 8. 2, 4, 6, 8. They're both of them are happy. But in order to do this, they have to give it away and take one. So there's a transfer. Okay? So that's basically what's happening. Now, there is another step to this, and it is balancing the charges. I apologize, I have to erase every time. But it is balancing the charges, okay? So what does that mean? What does it mean to balance charges? Well, if you remember, sodium on the periodic table has a +1 charge, or 1 plus charge. Let me fix that because I know I told you guys not to do that, and I sit here and do it anyway. Sodium has a 1 plus charge, and chlorine has a negative 1 charge. Okay? So what does it mean? Well, we're going to look at this plus 1 and this minus 1. So we take plus 1 minus, sorry, take that back. Let me go back it up a little bit. Sorry. You have 1 plus and you have a 1 minus. We're going to add those together, and to balance it, we should have a 0 net charge. So we should have 0 overall. Okay, I can't spell tonight either. Overall charge. Okay, so we have to balance it out. Okay, so let's take a look at something that doesn't balance out like this, and then we'll see what we have to do. Okay, so let's take a look at this. All right, so let's take calcium. Calcium has a 2 plus charge, and we'll go ahead and do chlorine again, and has a negative 1 charge, 1 negative charge. Okay, so if I take this 2 plus and I add it to a 1 minus, my overall charge is not going to be 0. Okay, so how do we work with this? Well, I'm going to show you a Lewis dot, and then I'll show, well, actually I'll show you this first, I think. How can I get this to balance out? Well, my 2 plus and my 1 negative means I'm going to have 2 of these to make this balance out, because 2 plus, you take this and divide, and 2 positive plus 2 negative 1s means I'm going to take a negative 1 plus a negative 1. I'm going to add those together, I get a minus 2, right? So let me fix this so it's not so messy. So we have 2 positive, and then we're going to have, so if I multiply this, I get negative 2, or 2 negative. 2 positive, 2 negative gives me a 0 charge. Okay, now this leads me into Lewis dot structures. Okay, so if I take calcium's Lewis dot structure, and where's my pink? Okay, calcium has 2 dots. Okay, and chlorine has 7. And I start transferring over electrons. Now remember, from Lewis dots, it can only have 8 valence electrons. So this one's going to come over here. And then this one has 8. This one still has 1 left over. So we have to do something. When you do a balancing and a Lewis dot, you can only add more of what you start with. You can't add a new element. You have to continue with what you have. So what we do is we stick a chlorine over here with 7 valence electrons, and this electron transfers over here. Okay, so when we have that transfer, you're going to get the Lewis dot that looks like this, and this is how we draw them. I'm using separate colors just because to show you if you can see the colors. But remember, we put this in negative. So it's a 1 negative, and over here we have a 1 negative, and right smack in the middle, calcium with no dots has a 2 plus. So the charges are going to balance out. A negative 1, or 1 negative, 2 plus, 1 negative. You have 2 negatives and 2 positives. It balances out for a 0 charge. Okay, so this is kind of the idea behind balancing of Lewis dots. We'll do some more in class. Okay, so now let's talk about the last thing that we have to talk about, which is our properties. Okay, when these happen, when these types of bonds happen and they create the transfer, we start to get this structure. Okay, so one of our structures, we get a distinct structure. It is called a crystalline solid, or crystal salt. We get crystalline. I-N-E. If you miss it, I'll rewrite it. It's crystalline. I'll rewrite it in class if you miss it. So the structure is crystalline. The melting point is very high. I mean, very high. Okay? The boiling point is also high. Okay? And then conductivity, electrical conductivity. And this is electrical, is also very high. They're good conductors of electricity. Okay? I'm going to move this. So very good conductors of electricity. Okay? And then the last thing is they're going to dissolve in water. Most of the time. Okay? Generally. So we call this soluble in water. Okay? And this word will come up again later on in chemistry. All right. To make this, so we can keep this kind of short, I'm going to stop here. Please watch for another video. Okay? I'll come to class and we'll work on them some more.